Hello everyone and welcome to AMOS, our course on Agile methods and open source. In the last few slide decks, sessions, segments, we've been looking at the various aspects of Agile methods, planning, execution, and review, release, retrospective. We are now at the stage where we will be looking at what Agile methods has to offer in terms of quality assurance of the software being developed. That's actually a bit difficult because unlike the traditional classic situation, like in plan-driven software development, Agile methods don't actually have a separate quality assurance department. In Agile methods, or certainly in Scrum, which we focus on here, all the quality assurance practices, techniques, requirements are being put on the regular software developer who has to perform it as part of the ongoing software development. So whatever has been traditionally assigned to QA engineers from a QA department, separate from a regular development or engineering department, is now being done by the regular software developers. And so onto this role are brought all the requirements and the practices that help ensure high quality software is being delivered. It's then actually quite hard if it's the same people playing one particular role, carry out a host of techniques and practices, both for driving, bringing the product or the project forward, and then also making sure it's sufficient in terms of quality and expectations thereof. So in the segments on software development, we already reviewed things that felt perhaps to some like quality assurance techniques. For example, test-driven development. Tests and testing is typically associated with quality assurance, but in the context of Agile methods is just one of the many practices that an Agile developer performs. So putting test-driven development into the regular development section was perhaps a bit arbitrary, and equally arbitrary may appear to some the distinction I'm making here, which is I will now look at reviewing practices, and I've put them here in the quality assurance sections. In any case, whether it's test-driven development or the reviewing practices we'll be looking at now, they are executed by the software developer, who thereby takes on responsibilities that have been classically allocated or assigned to an engineering manager, classic software developers, as well as QA engineers. So mostly here we will be talking about code review at different times using different practices in the development process. By definition, or the one I took here, a code review is a systematic examination of computer source code for the purposes of finding defects, mistakes, etc. So obviously quality assurance. We will also quickly see that it's not just classic quality assurance, but it's actually quite important from a developer collaboration perspective for knowledge sharing, etc. There are many different ways of how to carry out reviews or different forms of reviews, and we will look at two here, which are pair programming and pre-commit review by fellow developers. Looking at code reviews in general, still you might ask, when should you actually be doing it? So here are 4 possible points of time that make sense. You could be doing it as you're programming. You could be doing it before you decide this is a reasonable contribution to the code base, meaning before you commit your changes. You could be doing it at any random time, somewhere, somehow in the project. Maybe you have a manager who likes to have surprise code reviews. And classically, you would do a code review before delivery, before release, meaning as part of final quality assurance. In this course, we focus on the first two, in the moment and before the commit. And there's a reason for that, because it fits Agile methods, because it takes place, the review will take place at a point of time where it's close to where the code was being written. Meaning the feedback loop, it's always the same, the feedback loop is still short. It's still in the memory of a developer what they are doing or have been doing, and hence the feedback gathered from a code review has a short way to being realized and understood by the developer it's aimed at, and thereby can be fixed or acted upon at least with minimal overhead. Very different if you do it at the end of a project where developers may have to dig into old code they haven't looked at in a while. So again, there are two practices we'll be looking at. The first one is pair programming. Pair programming, very classic, came up with not extreme programming, but as so often extreme programming picked it up and popularized it. Pair programming is programming carried out in pairs of developers. Now, as two developers might be doing it, it's actually not that they're doing the same thing. It's two distinct roles that people play. One programmer is actually implementing, is in the details of writing code, while the other programmer is reviewing. That's why we are handling pair programming under reviewing practices here. And there are multiple terms to explain this relationship, these two roles. The classic one, the development one, is programmer and reviewer. Driver and co-driver, pilot and navigator. The pilot, for example, is in the midst of flying the plane. The navigator is watching out where we are supposed to be going. So there's a clearly different strategic outlook. One is in the details, is doing technical details, and the other one is looking at the strategic issues. Is this actually code we should be writing? Does it fit the design, etc., etc. The purpose of pair programming is quality assurance, naturally, but also collaborative learning. If you have two people looking at the same piece of code, they much faster might be able to solve a problem. And as they communicate, they share their different perspectives on some piece of code, which enables or empowers both to quickly learn from each other. That's also why it's being used as a practice for knowledge sharing, where sometimes you pair more experienced people with more junior people, hoping to get the junior people who may perhaps be new to a team, hoping to get the junior people up to speed with the code base faster. The effectiveness of pair programming is still debated, I think. The empirical evidence in research papers is diverse, though I believe mostly these days it's positive. So there have been studies which showed no particularly positive effect and some which showed positive effects. The economic calculation to be done, of course, is that you have two people, and the comparison is not one person against two, but rather two people programming independently. How fast would they be able to go? How high would the quality of their work be? As opposed to two people working together where only one is writing code and the other is constantly reviewing. So how to do pair programming? Well, first of all, probably not everyone is right for everyone else, meaning you need to find a partner you're comfortable with. If the peculiarities of your colleagues bug you, or a particular colleague bug you, then maybe that's not a good pair programming partner. But let's assume you found someone, you should then switching roles often. Not every 5 minutes, but maybe every hour or so. And that is to make sure that everyone gets into both seats regularly. Also, you should be communicating regularly. Now, that doesn't mean you should be talking all the time. Obviously, if you're programming and want to concentrate, you don't want to be talking. But the observing reviewer should be able to jump in at any point of time where it seems appropriate. As you're considering what pair programming applies to, don't force it onto everything. Small, simple programming tasks may not be worth it, but as you engage perhaps on a larger feature or more design-oriented or more difficult programming task, you may want to make sure you have a partner at your side. As you develop, don't overheat. Take a break if necessary, and also switch your development partners at time. Reality shows that people who like to pair programming like to return to the same partners, and that's mostly okay, but some switching is helpful, certainly from a knowledge sharing perspective. So not everyone likes it, but if you can do it, then it may be well worth your time, your while. And as you can see in these photos here, it really changes your work environment. So you must or should be sitting in front of one or two screens next to each other. And only one person gets the keyboard. There should really be one keyboard. And hopefully the reviewer doesn't bring out their cell phone all the time, but rather focuses, observes, and comments on what the driver, the main developer, is doing. Is pair programming easy to do? My personal opinion is it really depends on the psychology of developers. Dilbert had something to say about it a long time ago. As you can see, it's not even a color cartoon. The point he had, boss, is telling folks, yay, let's do pair programming. Pick a partner and then, whoa, 40 hours a week. And since everyone hates Wall-E, or rather not be working with Wall-E, they all jump on the intern Ashok here. One assumption here is clearly wrong. You should not be pair programming 40 hours a week. An effective workday, according to extreme programming, is 4 to 5 hours of programming. In addition, there's communication on coordination, email, other stuff. If you can put in 5 hours of effective programming in a given day, that's already a very good day. Oh, another one, Dilbert again on pair programming. Here you can see why everyone hated poor Wall-E, or maybe not so poor Wall-E, because he is pushing it. Sometimes I can whistle through both nostrils. So that's not what a good navigator does. Dilbert obviously would just be distracted, and Wall-E is not contributing. Knowledge is not contributing insights beyond the technical details that Dilbert may be focusing on here. Moving on from pair programming to pre-commit code review. When we talked about pair programming, we were talking about reviewing in the moment. You would be getting feedback as you're programming. Now comes pre-commit code review, which is code review that takes place before your code makes it into the code base. So you may have been programming by yourself, pair programming or not, and now your code is ready to go into the code base, or so you believe. And pre-commit code review is a process in which your code, rather than getting committed right away, is first put in front of the eyes of someone else, who then has to approve it. This practice, I believe, gained recent or not so recent, last 10 years, popularity again because of Google heavily leaning on this pre-commit code review. It's code review very close still to the point of time where a developer is actually or has been programming the code, and then they will get the feedback from another developer who will either accept the code into the code base or sets the flag for got accepted or is supposed to be accepted, and that allows the commit to go through, or rejects the code for whatever particular reason, from the most basic doesn't work, doesn't look right from a coding style, to this will screw up some other code, to there's really a bug here. And developers may or may not be hierarchically structured here, meaning the person to approve your code could simply be an equal peer somewhere, but the point is the system may require that someone else signs off on your code before it goes into the code base. There's obviously tooling for it, which we'll look at in the next few slides. And the most common acceptance notice of your code is LGTM, looks good to me. The challenge, of course, is that code review takes time, which a developer has to spend on reviewing the code, while they might rather be writing their own code. Maybe they also have pressure to deliver. So the challenge here is balancing reviewing with your own programming activities. So let's take a look. Here's a screenshot from one of the more popular code review tools called Gerrit. And the process is a stepwise process where someone submits code for review to be committed to the code repository. So other developers have opened their code review tool and they have an incoming patch commit request, if you will. And so someone thinks their code is ready to get committed, and for quality assurance purposes, now someone else needs to sign off on it. How to do that? Well, obviously the tool will then present in front of the eyes of that other developer the changes being made or being suggested. As you can see here, it can simply be a classic diff side-by-side comparison view as to the suggested changes. The tool shows developers what it is that the other developer wants to put into the code repository. That's then annotated, comment on the code, etc. And in a final step, which is either accept or reject, the reviewer can comment or provide a final comment on somebody else's submission. Could be the typical LGTM, looks good to me, or it could be a detailed explanation as to why they think this code is buggy and cannot be accepted into the code base. That's the basic pre-commit code review process that has been gaining popularity, mostly again thanks to Google and Facebook leading the way here. Pre-commit review means has a couple of benefits, not only the quality assurance that's being implied here, but also the sharing of code and knowledge as developers get to see more code than just their own. There are always topics, issues that a developer is not necessarily the most familiar one with. There's always the functional code, of course, but there's so many in large systems, so many side effects from a performance or security perspective that nobody can always be on top of, that it's really helpful to have other folks who may be more of an experts on these topics review your code. And it actually makes it much faster to disseminate new practices, new insights into the development organization. If, for example, you always put experts on, say, security into the loop, who will then provide this way close to the code rather than through generic tutorials, provide feedback close to the code to developers who then learn or catch up on, say, new things that have happened to the security framework of that code base or that organization. Developers who know that the code will be read by others and who know that they might not receive favorable comments if they are kind of sloppy will become more disciplined. So code review, pair programming, but also pre-commit code review will create more disciplined developers. The disintermediation by a tool rather than sitting next to each other often has an inhibiting factor, which may or may not be good. It's not good if people start getting too explicit, but certainly the disintermediation makes people hesitate less to put very clear words in writing what they think about the code. So by disseminating best practices, by improved knowledge sharing, pre-commit code review raises overall quality standards in the code base. And since everyone gets to see more code and sign off on more code, there really is a feeling or a stronger feeling of collective code ownership of this is our baby, our product, our software. And with that increased responsibility, of course, comes higher quality, better engagement, and typically also more satisfied developers, something that most organizations will want. Well, so this course is the Agile Methods and Open Source course. So even though we mostly focus on Agile Methods, but let's do a quick side-by-side comparison as to these quality assurance practices in Agile Methods and Open Source, because it's instructive. It is different, and that's quite interesting. Agile Methods use programming guidelines, and so does Open Source. And in both cases, it's based on the general realization code is so much more read than written that the investment in consistent, coherent use of programming guidelines really pays off. The purpose, though, is different from Agile Methods, from Open Source. Agile Methods wanted so you can get up to speed with code faster, while in Open Source, certainly it also is a sign of respect that you observe the programming guidelines as you are getting closer and possibly contributing to an open source project. A big difference is collective code ownership that Agile Methods favor or require, which follows from feature-oriented development. As you're implementing a feature, as you're trying to deliver an increment with business value, you may be touching pretty much every layer of code in the system. That's what you get from feature-oriented development. And it's possible because people are co-located, you can easily walk over and ask a question, and because you also always have right access to the whole code base. You're a self-organizing team, everyone's considered capable, you're being trusted, you can pretty much touch everything, at least in principle. And that leads to collective code ownership and all the practices around it that are trying to make sure you actually feel that collective ownership and feel responsible for your code, which is very different from open source. In open source, you tend to have strong individual code ownership simply because of distributed component-oriented software development. Open source software development almost always from the beginning is distributed, and then hence people split up work by components, which creates not necessarily friction, but certainly overhead, as people have to coordinate not along the lines of features and functionality, but along the lines of architectural delineations like component boundaries. And with that comes typically strict write access restrictions. People are responsible for components. That's what they can change, but may be not other people's code in the project. This is simply because we are not working feature-oriented. This leads to individual code ownership, which makes people feel strongly about their code, requires everyone else to respect it, but does lead to collaboration overhead across component boundaries. Agile Methods originally started with pair programming only, and pre-commit review is a recent addition that these days is often used, but not generally required or considered part of Agile Methods. While it's exactly the opposite in open source, there's basically no pair programming. How could there be pair programming if you're not co-located? But open source 100% requires that anyone who's not a core member of the team, who is just a regular contributor, have their contribution reviewed before it makes it into the project. And that's simply because they don't even have the right, they don't even have the commit rights to the code repository. That leads to this two-class society we observe in open source, where there's a difference between committers and contributors, but that's not the topic of this course here. If you're curious, please check out our FLOSS course also on YouTube. That's it. So when comparing Agile Methods with open source, we saw some differences, but these days it's getting closer, and the two primary code review practices we see in Agile Methods is the original pair programming, which Extreme Programming picked up, and then the pre-commit code review that we looked at that if you will, swapped over from open source, but now is also a mainstay in many organizations developing software in-house. So it's not legally open source, but does follow these practices of reviewing any commit before it's carried out. All right, thank you very much, and we will continue with another segment in next